Hi, in this presentation, I'm going to talk about one of my project which is based upon reinforcement learning. So in AI, there are three kinds of learning methods broadly if we classify: supervised learning, unsupervised learning, and reinforcement learning. So let's say you know about the data set, then you use the supervised or unsupervised learning methods. But what if you don't have the data at all? You don't know about your environment where you are experimenting. Then comes the reinforcement learning, where the agent itself interacts with the environment and then it learns from there. So the learning method here is very simple. It is like based upon reward and penalty. So if agent takes a particular action in a direction where you want, so you basically give it a reward, and if it makes some mistakes, let's say, then you penalize it, so that from the next time your agent actually hesitates or eventually stops making those mistakes. So that's how this trial and error learning happens. So here the agent needs to both explore and exploit the exploration. So agent takes random actions as well, and also it takes learned actions. So based upon this simple idea, it progresses and eventually it learns the entire environment and it evolves. So if you like, let's say, change the environment, so you can retrain your agent again, and accordingly it will adopt that random environment. So that's how it is self-evolving. Although my project is very simple, but very complicated ideas in the current AI world, such as RLHF and PPO algorithms work. If you talk about DeepSeek models, they are based upon this same reinforcement learning idea. For my case, I have used a very simple algorithm, Q-learning, and a very simple environment, a 2D environment, which I created in Pygame. So I randomly initialize 3 robots and I assign a goal to each of these, and I run epochs. And in reinforcement learning, we generally say episodes, not epochs. As the agents learn, the Q table basically gets updated, and thus ultimately we derive a policy out of the Q table that choose the actions such as the overall accumulated reward is maximum. That's how these robots actually are able to follow a shortest possible path, avoiding the collisions from the walls and these random humans, and they reach their assigned goals. So the reward model here is quite simple. If the robot collides with any wall, give it a penalty for each step it takes. Also penalize the robot so that it doesn't take longer route, and thus it learns about the environment. It will eventually become aware of the environment, where the walls are, where the goal is. So whenever the robot reaches the goal, we basically give it a huge reward, so that agent can learn actually what we are trying to basically do with it. In my environment, I have allowed the robots to take only 4 actions, so that things are very simple. So this system actually can be applied to warehouses where you are managing your inventory. The complete automation can be done using this algorithm, the routing actually. I hope you liked it. For more technical details, you can look into the full code which is available on my GitHub. Thank you so much.